final type of limit line that can be used is the ripple. Again, I'll choose to rename it ripple so that we can keep track of what's going on. The type is ripple. Again, as discussed previously, we need to add it to the cable loss trace, which is what we're working with. In this case, I'm going to go from 2 gigahertz to 2500 megahertz, or 2.5 gigahertz. The value is set to what will be, we think, the value we expect, and we'll see plus or minus some range. I'm going to set it to 25 by erasing the initial bit and hitting 25. Now, when I go back to my measurement for cable loss, I have a ripple spec available to me. As we discussed, it has to be assigned to the right trace type. I turn it on, and what we see is that it passes. It's again wider and at a higher frequency range, so I set it off to the side. I can choose to turn off the tolerance at this time so I can more clearly focus on my ripple spec, and I see the following. First, it's a ripple spec. The name could have been anything, but we've chosen ripple to identify the type of spec. The first value is the maximum value over the span that we've chosen to measure. So the frequency range from 2 gigahertz to 2.5 gigahertz has a maximum value of minus 22.62. The downward facing arrow next to that of minus 26.84 indicates the minimum value of the frequency range, and then it takes a point by point average of all the points found in that frequency range and calculates the average value. This may be the most appropriate use of cable loss measurements, is to use a ripple spec, knowing that you expect to have a calculated value of some number of dB, and then it indicates how much change you have, the min, max, and average value.